What happens when a Chinese spacecraft, orbiting Mars millions of kilometers from Earth, points its camera toward a faint point of light in the darkness of the cosmos and captures something that not even NASA expected to find? Stay until the end, because what you're about to hear could forever change the way you look at the night sky. This is the story of a visitor that arrived from another star, of images that crossed political borders, and of a mystery that is only beginning to reveal itself.
Good evening, dear friends. Felipe Suarez here, accompanying you as always on this journey through the far reaches of the universe. Tell me something, have you ever stopped to think about what is really up there? I am not referring to the stars we see every night, but to what travels between them, to what crosses the void for billions of years without anyone noticing. Do you believe we are prepared to receive visitors from other star systems? Because it turns out that one has already arrived, and what they found in it has the global scientific community very worried.
The night of October 29th, 2025 marked a before and after in the history of space exploration. Somewhere beyond the orbit of Mars, floating in the black immensity of the cosmos, an object approximately 5 kilometers in diameter was silently crossing our solar system. Its official name is 3I/Atlas, a designation it received after being detected for the first time by the Atlas survey system located in Hawaii. But this was not just any comet, nor an asteroid lost on its way toward the sun. This was the third confirmed interstellar object in the history of humanity, a traveler that came from another star, from a solar system completely different from our own. The trajectory of the object made it clear from the first moment that it did not belong to our cosmic family. Astronomers call this type of path a hyperbolic orbit, which means that the object is not trapped by the gravity of the sun. It entered our solar system, will pass close to our star, and then will depart forever into the interstellar void, unless something extraordinary changes its course. It is like a cosmic tourist who only came to visit, who has no intention of staying, and who carries with it secrets from places we can never reach with our current technology. The size of 3I Atlas is impressive when we put it in perspective. With its 5 kilometers in diameter, this object has approximately the dimensions of the island of Manhattan in New York. Imagine for a moment a rock the size of an entire city, covered with ancient ices and unknown materials, traveling at unimaginable speeds through empty space for perhaps billions of years. This piece of strange matter has probably existed since before Earth formed, since before the sun ignited its first nuclear flare, since before our solar system was even a dream in the primordial gas cloud that eventually gave us origin. But what really captured the attention of scientists was not just its size, nor its interstellar origin. It was its color, a curious blue-green tone that seemed to change over the weeks of observation, as if the object were responding to invisible forces, to tides we cannot see or measure with our current instruments. This behavior was disconcerting, because normal comets do not behave this way. Normal comets follow predictable patterns, release gas and dust when they approach the sun, and their brightness increases and decreases in ways that astronomers understand perfectly after centuries of observation.
Now then, my friends, here is where the story gets truly interesting. Can you imagine a comet that glows, that accelerates, and that expels material even when it is far from the sun? Because that is exactly what 3I Atlas was doing. How is it possible for an object to release so much water vapor at distances where sunlight barely reaches? What is heating it from within? Or perhaps is it interacting with the solar wind in a way we have never seen before? The answers to these questions could rewrite the astronomy textbooks.
For months, telescopes distributed around the world recorded something extraordinary. From Chile to Spain, from Hawaii to Australia, observatories captured weak but consistent bursts emanating from 3I Atlas. These pulses of activity followed a regular pattern, almost like the heartbeats of a cosmic heart, as if the object were breathing in the darkness of space. Scientists began informally calling it the interstellar heartbeat, although no one could explain what mechanism was producing this activity so rhythmic and so constant. When the object reached its closest point to the sun, what astronomers call perihelion. Something happened that no one had anticipated. On October 29th, 2025, 3. I Atlas erupted in a spectacular display of 7 jets of material, some of them pointing directly toward the Sun. This configuration was completely anomalous, because according to the physics we know, a comet's jets should point in the opposite direction from the Sun, pushed by the radiation pressure of our star. It was as if the object were defying the fundamental laws that govern the behavior of all known comets. The headlines in scientific journals practically wrote themselves. The interstellar comet that acts like a machine, some proclaimed. A visitor that does not follow the rules, said others. The global astronomical community found itself divided between amazement and skepticism, between those who saw in these anomalies evidence of something extraordinary and those who sought more conservative explanations based on known physics. While the Western world anxiously awaited new images from NASA's Mars Reconnaissance Orbiter, images that were delayed due to bureaucratic complications and government shutdowns, something unexpected happened on the other side of the planet. The China National Space Administration made a decision that would change the course of this story. They decided to point the camera of their Tianwen-1 spacecraft toward the interstellar object, and more importantly, they decided to share what they found with the rest of the world. The Tianwen-1 spacecraft had been orbiting Mars since February 2021. This mission represented China's first independent interplanetary success, an achievement that included not only an orbiter, but also a lander and the small rover called Zhurong. The main mission of Tianwen-1 was to study Mars, map its surface, analyze its geology, investigate its atmosphere, and search for evidence of present or past water. No one had designed this spacecraft to observe deep space objects. No one had thought that someday it would capture images of an interstellar visitor. However, with precise orientation and careful adjustments to exposure times, Chinese scientists achieved something remarkable. They captured the clearest vision ever obtained from Martian orbit of an object coming from another star. The images were released through China Daily and subsequently amplified by other Chinese media outlets. What they showed electrified the international scientific community because they confirmed exactly the anomalies that Western telescopes had been reporting for months.
Stop with me for a moment, dear listeners. Think about what I just told you. A Chinese spacecraft orbiting another planet millions of kilometers away managed to photograph an object that travels between the stars. Do you realize how extraordinary this is? And most importantly, what do you think those images showed? Because what they revealed not only confirmed the mysteries, but added completely new layers to the enigma. Are you ready to learn what the Tianwen-1 camera captured in the darkness of deep space?
The Chinese images showed a greenish nucleus with characteristics that no known comet had exhibited before. At the center of the object shone a compact structure, surrounded by a narrow reflective band that appeared almost metallic under certain lighting conditions. But what really captured the attention of experts was the ion tail of the object, that trail of charged particles that all comets produce when they approach the Sun. In the case of 3I Atlas, the ion tail showed behavior that defied established physics. Instead of pointing directly away from the Sun, as solar radiation pressure dictates, the tail curved slightly toward our star. This small detail, which might seem insignificant to the casual observer, represented a fundamental anomaly that astrophysicists could not explain with conventional models. Standard physics predicts that a comet's tail must always point in the opposite direction from the Sun. Solar radiation pushes particles of gas and dust outward, creating that characteristic trail we see in comets when they cross our sky. A tail pointing toward the Sun suggests something completely different, some type of interaction with charged particles that we do not understand, or as some bolder scientists began to suggest, a possible controlled emission of material. The renowned astrophysicist Avi Loeb, Harvard professor and director of the Galileo project, dedicated to the search for extraterrestrial technology, publicly commented on these observations. If confirmed, he said in an interview for News Nation, this would be the first visual confirmation of engine-like behavior in an interstellar object. Perhaps it is a comet releasing material in an exotic manner, he added, or perhaps we are witnessing propulsion, natural or not so natural. The instruments of Tianwen-1 revealed additional data that added more mystery to the enigma. The medium-resolution camera of the spacecraft detected brightness fluctuations in the object that followed a tight cycle of approximately 6 hours. This periodicity could indicate rotation of the body, but it was also consistent with repetitive jet activity, as if something inside the object were releasing material at regular intervals. The spectral analyses, that technique that allows scientists to determine the chemical composition of distant objects by studying the light they emit or reflect, showed peaks corresponding to nickel and magnesium. These metals are unusual in normal comets, where water, carbon dioxide, and other lighter compounds typically dominate. The presence of these elements suggested that 3I Atlas had formed under very different conditions from those that prevailed in our primitive solar system. Perhaps the most disconcerting was the thermal signature of the object. The instruments indicated surface heating that was inconsistent with the amount of sunlight it was receiving at its distance. Something was heating 3I Atlas from within, some internal process that scientists could not identify with certainty. And despite all this violent activity, all those jets and emissions, the object showed no clear trace of fragmentation. The main body remained intact, solid, resistant.
Allow me to ask you a direct question, friends. When you hear all of this, when you learn that an object is releasing material in a rhythmic manner, that it has rare metals in its composition, that it heats up without apparent explanation, what is the first thing you think? Do you believe we are witnessing an extraordinary natural phenomenon that we simply have not seen before? Or perhaps your mind, like mine, begins to consider bolder possibilities. Science obliges us to explore all hypotheses, including those that seem taken from science fiction.
From the data collected by Tianwen-1 and by telescopes around the world, two main interpretations emerged that divided the scientific community. The first, which we could call the natural hypothesis, proposed that 3I Atlas was simply an extraordinarily ancient object, rich in volatile materials, that had spent billions of years wandering through interstellar space. According to this explanation, during that inconceivably long time, the cosmic rays that permeate the space between stars would have constantly bombarded the object's surface. This high-energy radiation would have gradually altered the chemical composition of the outer crust, creating pockets of reactive ices buried beneath the surface. When 3I Atlas approached the Sun for the first time in billions of years, solar heat penetrated these subterranean caverns, releasing bursts of gas that mimicked the behavior of controlled jets. It would be, according to this vision, nature's own version of an engine, a completely natural phenomenon, although extraordinarily rare. The second interpretation was much more provocative. The technological hypothesis suggested that the jets of 3I Atlas were deliberate, the result of internal chambers designed to vent material in precise directions for the purpose of stabilizing or propelling the object. Not necessarily evidence of active alien life, but perhaps an ancient technological relic, a probe sent billions of years ago, a piece of debris from the space exploration of another civilization, a civilization that perhaps no longer exists, but that left messengers wandering through the galaxy. Both options were profound in their implications. The first redefined our understanding of cometary physics and of the processes that can occur during interstellar voyages of billions of years. The second redefined our place in the cosmos, suggesting that we are not the first intelligent beings to wonder what exists beyond their home solar system. Science advances through the replication of results. For months, some skeptics had alleged that the images obtained by Western telescopes could be overprocessed or poorly calibrated. Perhaps the anomalies were simple instrumental artifacts, errors in data processing that created the illusion of strange behaviors where there was only ordinary physics. These criticisms were valid and necessary because science demands solid evidence before accepting extraordinary conclusions. The images from Tianwen-1 completely changed this situation. The Chinese dataset had been taken from a completely different vantage point, using different instruments with independent calibration methodologies. And yet, it confirmed exactly the same anomalies that Western observatories had reported. The green tone of the object was real. The structural stability was real. The anomalous jets were real. All observations were consistent, regardless of who made the measurements or from where they were taken.
This is crucial, friends, and I want you to understand it well. When scientists from different countries, using different instruments from different locations in the solar system, obtain exactly the same results, that tells us something very important. It tells us that we are not dealing with an error, that we are not dealing with an illusion. Do you realize what this means? The strangeness of 3I Atlas is not the product of faulty instruments or careless scientists. It is real, it is universal, and it is out there floating in the void while we try to understand what the hell it is.
The Chinese contribution significantly expanded what scientists call the observation baseline. It was now possible to triangulate the appearance of the object from 3 distinct points: Earth, Mars, and solar orbit. This 3-dimensional perspective provided something invaluable in astronomy: parallax and depth. It allowed confirming with greater certainty the real dimensions of the object, its true velocity, and the nature of its anomalous behavior. Even more significant was the fact that the data had been released without delay. In a world where space agencies frequently withhold information for months or years before sharing it publicly, the Chinese decision to quickly publish their observations represented a notable example of scientific openness. It was collaboration across nations, across planets even, exactly what science should always represent. Imagine for a moment being aboard a spacecraft orbiting Mars. The sun burns to your left, shining with a slightly lesser intensity than from Earth due to the greater distance. Ahead, through the black abyss of space, a faint glow moves slowly against the background of fixed stars. It is 3I Atlas, now magnified 40,000 times by the ship's optics, revealing details that no human eye could perceive directly. The composite image constructed from Tianwen-1 data showed a central nucleus glowing with blue-greenish light. Faint jets radiated from the surface in approximately symmetrical patterns, like the petals of a cosmic flower opening toward the void. A main plume extended toward the sun, glowing more intensely than the rest of the nucleus, diffusing into a fan of ions that defied all conventional explanation. Surrounding the entire ensemble appeared a halo of dusty fluorescence, almost ghostly, as if the light itself were escaping in layers from the object's surface. Chinese analysts measured the length of the main jets and found values close to 100 kilometers, an extension much greater than expected for a body of that size. Their conclusion was that they were witnessing massive material release events, possibly sustained for hours. The data corroborated what European and American astronomers had seen only faintly from their terrestrial observatories. 3I Atlas was not simply evaporating passively under the heat of the sun, as any normal comet would do. It was acting, exhibiting behavior that suggested some type of active process, perhaps even directed. That distinction between evaporation and action was fundamental. Evaporation is a passive process, something that happens to an object when it receives external heat. Action suggests something more, some internal mechanism that controls when, where, and how material is released. Scientists debated intensely about what natural mechanism could produce this type of behavior, but no explanation was completely satisfactory.
Let us talk about numbers for a moment, because the numbers in this story are truly astonishing. Did you know that at the distance where 3I Atlas was located, sunlight delivers only a small fraction of the energy we receive here on Earth? And yet this object was outgassing with an intensity typical of comets 10 times closer to the Sun. How is this possible? What energy source feeds those jets? What is heating this visitor from within? These are questions that keep the best scientists on the planet awake at night.
The mechanics of cometary jets have been well established for decades. When a comet approaches the Sun, sunlight gradually heats the ices found beneath its surface. These ices, composed mainly of water, carbon dioxide, and carbon monoxide, sublimate directly from solid to gaseous state, escaping into the vacuum of space and dragging dust particles with them. This process creates the characteristic cometary tail we can observe from Earth when a bright comet crosses our skies. The problem with 3I Atlas was that it was too far from the Sun for this mechanism to work efficiently. At the distance of Mars, the intensity of solar radiation falls significantly compared to what is received near Earth. The amount of energy available to sublimate ices is insufficient to explain the violent activity observed. It was like seeing a bonfire burning intensely without apparent fuel, something that simply should not happen according to our current understanding of physics. Scientists proposed two possible explanations for this enigma. The first suggested that the object contained extraordinarily volatile compounds, substances like carbon monoxide or molecular nitrogen that vaporize at much lower temperatures than water. Some comets in our own solar system, like the object catalogued as C2016R2, have shown unusual compositions rich in these materials, exhibiting behaviors that initially puzzled astronomers. The second explanation was more intriguing. It proposed that 3I Atlas was internally fed by some heat source of its own, perhaps radioactive decay of heavy elements trapped in its interior, or perhaps unknown chemical processes that released energy in a sustained manner. If this second option proved correct, we would be observing a self-regulating thermal system, something that behaved very similarly to what we would expect from an artificial engine. It is important to emphasize that no serious scientist was claiming with certainty that 3I Atlas was of artificial origin. Science demands extraordinary evidence for extraordinary claims, and although the anomalies were real and inexplicable, this did not automatically mean we were facing extraterrestrial technology. However, the appropriate scientific stance was also not reflexive skepticism that dismisses possibilities without considering them. The duty of scientists was to expand known categories when encountering behaviors that did not fit into any existing classification. Perhaps 3I Atlas represented the prototype of a new class of objects never before observed. Interstellar hybrids between asteroid and comet, shaped by billions of years of exposure to high-energy cosmic radiation. Objects that had experienced physical and chemical processes completely different from those that act in our solar system. Objects that defied our classifications because we had never had the opportunity to study something similar. Or perhaps, just perhaps, 3I Atlas was the fossil of another civilization's curiosity, a machine built eons ago by intelligent beings who, like us, sending the Voyager probes toward the stars, decided to launch their own messengers into the interstellar void. A probe that had wandered for longer than Earth has existed as a planet, still functioning at some basic level, still emitting material, still navigating according to programming established billions of years ago.
I want you to reflect with me on something, friends. If it turns out that 3I Atlas is indeed an ancient probe from another civilization, what does that tell us about the universe? If a machine can survive billions of years traveling between the stars, still operational, still functioning, how many others exist out there? How many have passed through our solar system without anyone noticing? How many are passing at this precise moment while you listen to my voice? And if they built probes that last billions of years, what else might they have built?
Within hours of the release of the Chinese images, the data spread throughout the scientific world. NASA confirmed that the observations were in perfect alignment with their own orbital models of the object. The European Space Agency cross-verified the color calibration used by Chinese scientists. Japan's Subaru telescope, one of the most powerful instruments in the Northern Hemisphere, independently verified the object's brightness curve, finding exactly the same periodic fluctuations reported by Tianwen-1. But what captured the imagination of the general public was not the technical science, not the spectra, nor the light curves, nor the hyperbolic orbits. It was the image itself of the object, that luminous emerald teardrop floating in the darkness beyond Mars, a visitor from the stars captured in pixels that anyone could see on their cell phone. Social media transformed the image into an instant cultural phenomenon. It became an icon, a meme, a mystery, a metaphor for human curiosity itself. Some users joked that it looked like a green lantern floating over the desert of space. Others saw in it a sign, a mirror raised toward humanity that reflected our shared search for meaning in an apparently indifferent universe. When several reporters asked Avi Loeb if he thought the object was alive, the Harvard professor smiled before responding. "It is alive in the way that ideas are alive," he said. "It moves, it changes us, and it does not die when we stop looking." That is the beauty of moments like this. They remind us that wonder is a universal currency, something all human beings share regardless of borders or languages or cultures. The next important milestone in the history of 3I Atlas was scheduled for December 19th, 2025, when the object would reach its closest approach to Earth. At a distance of approximately 270 million kilometers, the interstellar visitor would pass close enough to allow an unprecedented worldwide observation campaign, but far enough to pose no risk to our planet. The Galileo project, led by Loeb from Harvard University, had prepared a global observation network for this event. Telescopes in Arizona, Chile, and Israel would be ready to track the object, combining optical and infrared data to obtain the most complete image possible of this mysterious visitor. The objective was simple in its formulation, but extraordinarily complex in its execution. Quantify the object's acceleration with unprecedented precision, analyze its rotation, and identify if its jets pulsed at fixed and predictable intervals.
Tell me something, dear listeners. Can you imagine sitting in front of a telescope on December 19th, knowing that what you are about to see could change the history of humanity? Because that is exactly what the scientists involved in this observation feel. If the object fragmented during its close passage to the Sun, they will see the scattered pieces glowing in synchrony. But if it is intact and accelerating in inexplicable ways, they could be witnessing controlled propulsion. Are you prepared for either answer? Is humanity prepared?
The importance of the December observation campaign lay in the possibility of obtaining definitive answers to the questions that had tormented scientists for months. If the emission patterns of 3I Atlas turned out to be random, chaotic, variable, this would strongly suggest a natural origin. Natural processes typically produce unpredictable behaviors, governed by the physics of chaos and the thermodynamics of complex systems. But if the patterns turned out to be regular, predictable, intentional, then the natural explanation would become much more difficult to sustain. Perfect regularity is rare in nature, but common in technology. Engines function in precise cycles. Control systems adjust parameters according to established programming. Space probes emit data at intervals measured with millisecond accuracy. Spectroscopy would determine the exact chemical composition of the object's jets. If they contained materials typical of comets, such as water, carbon dioxide, and simple organic compounds, this would strengthen the natural hypothesis. But if they contained unexpected elements or compounds, materials that should not exist in a naturally formed object, the conversation would change dramatically. High temporal resolution photometry would track the object's brightness variations with a precision never before achieved. Every fluctuation would be recorded and analyzed, searching for patterns that could reveal the true nature of the visitor. It was detective work applied on a cosmic scale, all of humanity acting as investigators at a crime scene that extended for millions of kilometers. What China's Tianwen-1 mission had achieved transcended the purely scientific realm. It was more than data and more than images. It was a philosophical reminder that exploration of the cosmos is a fundamentally global enterprise, that curiosity does not recognize political borders, that scientific truth is a cooperative project involving all of humanity. We frequently hear talk of competition in space, nations racing against each other for prestige, for resources, for strategic advantage. But genuine discovery does not work like a race. It is more like a relay race, where each participant passes the baton to the next. Each space agency, each telescope, each amateur observer who looks at the sky with a pair of binoculars contributes to a shared project. From Hawaii to Beijing, from Cambridge to the Atacama Desert, everyone was running the same race, not against each other, but together against the common enemy, ignorance.
You know, friends, there is something beautiful in all of this that I do not want us to miss. Think about what is happening. Chinese scientists share data with American scientists. Europeans verify results obtained in Asia. Japanese confirm observations made from America. The universe is teaching us something important here. It is showing us that when we set aside our differences and look together toward the stars, we see more clearly. Do you not think that is a lesson we should also apply down here in our daily lives?
If 3I Atlas turned out to be a natural object, its study would teach us how nature engenders complexity beyond the limits of our terrestrial imagination. We would learn about physical and chemical processes that occur during voyages of billions of years through the interstellar void. We would better understand how planetary systems form and evolve in other parts of the galaxy. We would obtain a direct window into conditions we can never recreate in terrestrial laboratories. If 3I Atlas turned out to be artificial, the implications would be even more profound. It would tell us that we are not the first engineers to wonder what exists beyond the horizon, that at some moment in the distant past, somewhere in the galaxy, another civilization reached the technological capacity to send probes toward the stars. That civilization, although perhaps extinct billions of years ago, left messengers that still wander through the cosmos, silent carriers of a message that simply says, "We existed, we explored, we dreamed of what lies beyond." Both conclusions would elevate humanity rather than diminish it. Either we are children of an extraordinarily creative universe, capable of producing wonders that defy our understanding, or we are heirs to a cosmic tradition of exploration that began long before our species took its first steps upon the surface of this small blue planet. Sometimes it is useful to exercise the imagination and visualize scenes that capture the essence of what we are witnessing. Imagine standing on the dusty surface of Mars, with the pink sky extending above your head and the rocky formations of the Martian landscape around you. You look up and see a bright point moving slowly against the background of fixed stars. It is Tianwen-1, silently orbiting hundreds of kilometers above, its camera pointing outward toward the void. Somewhere beyond that small lens, invisible to any human eye but captured in digital data that will soon cross millions of kilometers toward Earth, 3I Atlas floats silently. It does not know, nor does it care, that billions of human minds are observing it, analyzing it, debating its nature. It is simply what it is, an object in motion through the cosmos, a visitor that arrived from the stars and will soon return to them. And yet, through the very act of observation, we become part of its story. Our curiosity connects us to that distant object, creates an invisible bond that crosses millions of kilometers of void. It also connects us to each other, scientists from different nations working together, ordinary citizens looking upward and wondering what secrets the night sky holds.
Before continuing, I want to ask you something very personal. When you look at the stars at night, what do you feel? Do you feel the immensity of the universe? Do you feel curiosity about what is out there? Or do you perhaps feel a connection, a sensation that we are part of something much greater than ourselves? Because that is exactly what 3I Atlas is offering us. an opportunity to experience that connection, to feel part of a cosmic adventure that transcends our individual lives. Does that not seem like something beautiful to you?
Perhaps that is the true lesson that 3i Atlas is bringing to humanity. Not a message encoded in radio signals, not a deliberate transmission of information, but something more subtle and perhaps more profound. The universe does not send us direct messages because it does not need to. Instead, it sends us opportunities. Opportunities to grow, to unite, to learn. Opportunities to overcome our differences and look together toward the stars. 3i Atlas, with its anomalous jets and its emerald color and its defiant behavior, is exactly that type of opportunity. It forces us to question what we thought we knew. It pushes us to collaborate beyond national borders and political rivalries. It reminds us that there are mysteries in the universe we have not yet solved, and that solving them will require the best of our species, our curiosity, our creativity, our capacity to work together. The scientists analyzing the data from Tianwen-1 knew they were participating in a historic moment. It did not matter if 3i Atlas turned out to be natural or artificial. The simple fact that a Chinese spacecraft designed to study Mars had captured images of an interstellar object and had freely shared them with the world represented a triumph of the human spirit. It was proof that, when it really matters, we can overcome our divisions and work toward common goals. The international astronomical community responded with enthusiasm to the publication of the Chinese data. Research teams in dozens of countries began analyzing the images and spectra, searching for clues that could reveal the true nature of the visitor. Discussions in scientific forums intensified, with experts debating the implications of each new finding. It was science in action, the process of discovery unfolding in real time before the eyes of the world. Meanwhile, 3i Atlas continued its path through the solar system, indifferent to all the attention it was receiving. Each day it came a little closer to Earth. Each day telescopes observed it in greater detail. Each day new questions arose about its nature and origin. The mystery deepened even as more data accumulated, as if the object were revealing its secrets gradually, in measured doses, almost deliberately.
Do you know what fascinates me most about all of this? It is that we are living this moment together, you listening in your homes, me here sharing this information with you, and out there, millions of kilometers away, an object that has traveled for billions of years is finally passing near our little corner of the cosmos. Do you not feel that it is almost as if the universe had sent us an invitation to awaken, to look upward, to ask ourselves what else is out there waiting to be discovered?
3. Atlas continued its journey after the close encounter in December, gradually moving away from Earth and the Sun on its hyperbolic trajectory toward the stars. Within a few years, it would be too faint to be observed even with the most powerful telescopes. Within a few decades, it would have completely left our solar system, returning to the interstellar void from which it had come. Within billions of years, perhaps it would visit another solar system, where perhaps other intelligent creatures would look up and wonder what that green point was moving against the background of stars. The images from Tianwen-1 had demonstrated something important. They had demonstrated that when nations cooperate, when borders dissolve before shared curiosity, when the goal is not to conquer but to understand, humanity can see more clearly. Science does not belong to any nation. The sky is the same for everyone, and the photons that travel through the cosmos do not carry passports nor respect political divisions. The truth about 3i Atlas, whatever it may be, belongs to all of us. It is the common heritage of humanity, a gift from the universe that we can study and contemplate together. And perhaps that is more important than any specific answer about its nature. Perhaps the true lesson is that when we look toward the stars, we see ourselves reflected in their light. We see our curiosity, our wonder, our desire to know.
Before saying goodbye, friends, I want to ask you something. If this story made you think, if it made you wonder, if it made you feel that spark of amazement that we all carry within, I invite you to subscribe to the channel. There are many more stories like this waiting to be told, many more cosmic mysteries to explore together, and I would love for you to accompany me on that journey. Leave me a comment. Tell me what part of this story made you remember something from your own life. Maybe it was a night under the stars. Maybe it was a moment of childhood wonder. Maybe it was simply that feeling that there is something greater than ourselves waiting for us out there. Share your experiences with me, because deep down we are all travelers in this immense cosmos, all looking toward the same stars, all asking ourselves the same things. Until next time, friends, may the sky be with you.